Hello there, ladies and gentlemen. I'm gonna show you today a little tutorial thingy on how to make glass, um, sort of refracting glass with also a sort of blurriness to it. Yeah, don't worry about the thing not following the camera. That's because we're not using the standard one. We're making our own transparency. So here you can kind of see that there's something behind it. Maybe it's too dim. Why is it so dim? Never mind. You can see that it does have some transparency to it. You can see the sun behind it, right? Right, yeah. And here's a clear version of it. And it's seen by the if you look at the right side of the glass, it's seen by the reflection of the screen space reflection that Unity comes with. So it's working within the deferred shaded pipeline, so you don't have to make your own reflections, which is a good thing. Leaves the hassle to like automated systems. Alright, so you can see 100% clear, a bit blurry, quite blurry, right? So how does it work? Well, we can take a look at the shader itself and take a look. Oh my god, that's not actually quite, that's not a whole lot actually, but this is a mess, so we're gonna go through all of this and show you how to make one on your own. Okay, let's start out, shall we, by making a new material, just so we have something, and we call it new glass, and just applying it to both of these two big planes that we have. Whoops. And then let's create a new shader. Shader Forge, new shader. We could basically start out with an unlit shader and just add whatever we want afterwards. Let's do that. Unlit shader. Let's call it what should we call it? Just new glass. New glass. Let's just call it new glass, shall we? Okay, we're gonna keep this color node. Just save it somewhere in here. And I've got a cheat sheet, so I don't have to remember everything with my brains. So where do we start? Well, we can start out by making the transparency, shall we? So there's two ways of doing transparency. You can use a thing called screen color, and this, if you hook it up to either custom lighting or emission, but since we're gonna use deferred rendered hit lighting and then deferred, then we can't use the custom lighting. Just hit compile and see what it does. Let's set that shader new glass. So it's already sort of applying itself to whatever we put it onto, right? So if we multiply the color by the scene color, hit compile, and set this color to something. Oh, look at that! Now we have. Oh, this looks like glass, right? Sure. It does actually. Does this actually work now with deferred shading? Yeah, previously it didn't. So you had to sort of make your own that's actually kind of strange why that actually works. Hold on. I'm just playing around. Hold your horses. I think it actually kind of bugged out, perhaps. we go. Hold on. Sphere. Just put that behind there. New gloss. Okay, yeah. The specular map isn't refracting properly, or isn't being shaded properly. Hold on. Yep. So this still doesn't work. So we're not gonna keep using scene color, because in the way we're gonna do the whole blurry glass thingy, we need to sample this the scene several times, and it's easier to just sample the scene once and just use that sample several times instead. So let's do that instead. We're not gonna use the base color, so just hook up like a vector 3 node with 0 into it. It has to be black, otherwise it's gonna look kind of strange. So there's two ways of doing transparency. There's scene color, and there's a if you use a render texture and apply it to a camera, which is basically just a clone of your main camera. So you have a camera which always looks behind transparent objects. Let's call it transparency buffer. Sure, why not? Hook it up to a 2D node. Now that should work. And then we're gonna end up multiplying the color to the whatever this is, so we can have a colored glass, and then hook that up to the emission. Metallic and all that. It's just, you know what? Right now, let's just keep it like this. Hit compile. Now there's nothing here, right? Because we haven't hooked up the render texture that we need. So create a render texture. Just right click, create, and then render texture, and set the size to like whatever aspect ratio your screen is in. So this is a 16:9 aspect ratio. Depth buffer. We don't need that. No depth buffer. Okay, if you have a depth buffer inside of your render texture, inside of your extra buffer, as it is, the size of it, now it's 4 megabytes. If I set it up to like no depth buffer, it's now just 2 megabytes instead. Saves on computing power. Keep that in mind. Alright. New glass. Now we have a transparency buffer texture input. Let's hook that up onto it. And boom, it looks kind of strange. Why does it look like that? And why isn't it the screen? We have already a transparency camera, which the transparency buffer thingy is hooked up to, but it's not aligned with the screen. Why is that? Well, we need to set up that logic by using screen position as the UVs. Now if we hook this up to there and hit compile, and you have to set it to scene UV, otherwise normalized splits it in half, so one half of the screen, it would be kind of tiled. It's the same thing except squished. Now it's 1:1 on the screen, so set it up to scene UV. Now from this side of the screen to that side of the screen should be the whole UV information. So there we go. But it's still not following our view. That's because it's not set up to do that. It's set up to follow our main camera. And if you hit the game tab, it is following the main camera. And it's working. Alright, cool. Now we have glass using our own render texture. Although it is at a lower resolution, as you can see here. Sharp, sharp, ooh, big pixels. But don't worry about that. Okay, so now we've already set up that logic. we need to displace these in order to make the blurriness of the glass, right? So let's disconnect that. Go place this somewhere safe. Hold on, the cheat sheet says. Alright. Let's set it to create a set node, hook that up into it, and call it screen position, screen pos, or whatever. And then we create a get node, screen position, and component mask. And hit RNG. Create a new set node, or actually two set nodes. And this is going to be called screen position U. And the other screen position V. The R channel is the U and the green channel is the V. There we go. And now we can hook this up to here. Alright. Get node again. Screen's position U. A new one. Screen's position V. Basically just screen position is just like it gets the values of this. So think of it as like this links to here, but we could create this screen position U in other areas, so it sort of links into many places in the code, centralizes everything, right? It's a good thing. Less of these connections everywhere, right? Less wires. So we need to make the blur, but since we can't really use a inbuilt Gaussian blur, there's no thing called that, so we need to make our own. So we need to move each of these pixels in 8 directions. How do we do that? How do we make that blurriness? Well, we need to move it, right? So we use adds and subtractions to move pixels, to move UVs. So let's start out by moving one of them into, so add, but yeah, hold on. We also need to append it later to add it into, make it into like a UV of its own. But what do we hook up into the add? What do we make? How do we control the amount of blurriness? Well, we need to we could just use a slider, but we need to also set up so we could later use it in multiple areas, right? So move this, create a slider, call it, you know what, let's call it glossiness strength. Create a set node and call it glossiness. And then a get node, get glossiness, 1 minus it. Was it? Yeah. Yeah. Pretty sure that was it. And then a new set node. And call this offset. Why not just use the glossiness? Well, we're gonna get to that later. Create a get node and then use offset. Hook that up onto the add, and now we already have that done. Okay, good. So now you see this then connects there, and then down here and up here. And then to make this whole thing fully realized, we need to hook the screen position V onto the append node without being changed or added or subtracted from. because we only want to move in one of the directions in one of these samples. Create more texture 2D nodes, hook that texture asset onto it, and add them together. So now we have made one, now we need to make another. Create a new add node, and now we need to add on the V axis of the UVs. Add there, and then hook that up to the second input on the append node, and then a clean non-affected U version. There we go. Now we have two directions. If we look at this changes in the vertical and this changes in the horizontal. Goodie! Hook that on to the second one. And now we get to the subtraction. We do the same thing. One with U and one with V. Create an append node. There, create, oops, D. There we go. Like so. Like so. There we go. Offset, offset. New texture, 2D, two of them. Hook the texture asset node. There we go. Now we have this whole thing in several directions. Hook them onto the add node, and now we need to do the, well, we have to get the sum of the parts, right? So instead of using divided by 4, let's do a multiply by 0.25. That's divided by 4. But since divisions are somewhat expensive, although modern machines deal with them without a hassle, we need to do optimizations, right? So there we go. Boom, boom, boom. Disconnect that. Move the whole thing away. Create a set node, just so we have this done. Call it color. Get node, get color, hook it up to the emission. There we go. Now hit compile. It should be working. If we now do the glossiness, and it's displacing. Just what we wanted. And it also should now be seen. Oh wait, we haven't. Yeah. Get node, get glossiness, hook that up to gloss. There we go. Hit compile. Move that away. So now as we go into our game and start playing, the glossiness should also apply to the blurriness, right? That's the whole point of it, having blurriness, blurry reflections, and blurry refractions. But 4 directions isn't enough. Well, it could be enough, but it looks kind of strange, doesn't it? Yeah, it kind of looks strange. So how do we make it look better? How make look good? One of the ways we can do it is adding a noise, a randomness to the positioning of them, right? So it could be there, within the parameters of this here. So create a noise node. And a multiply node. Hook the glossiness 1- into the B and this into there. And also a get node, screen position into the X and Y values. So this noise is now in screen space. Hook that onto the offset and hit compile. Boom. Randomness, more blurriness, right? Even though it's a noise channel, so it yeah, you'll see like small dots everywhere because it's noisy. It's not a full-fledged blur, but it's the closest thing we get. Well, the closest thing we have, rather. Yeah. Works as intended, but it stays the same blurriness no matter where we are in relation to the glass, right? How do we make a new logic for, like, we want it to be less blurry when we're further away, because the blurriness doesn't exactly move with it, right? When you're further away, it should be smaller. So how do we make that? Well, that's quite simple. We just use a depth node and divide it by the depth node. Hit compile. And there we go. Bim bada boom. It's working. So the closer you are to the glass, the more blurry it should be. Further away you are, the sharper it is. And it's still being controlled by the slider that we set up. So now it's really blurry, now it's a bit more sharp, but still blurry. Good. Logic. But we do need more samples. So how do we do that? How do we make more samples? We already used 4 directions, but how do we make the diagonal directions? It's simple. Create more texture 2D nodes. Actually, we need to create 4 of them because there's 4 more directions. And an add node and a subtract node. These are now going to be... Oh yeah, right. We also need to get just the whole screen position node too. That there. Boom, boom, boom. There and there. Then add them all together again. Yeah, we don't need that. Multiply. Just use the same value. Sorry. Since we're gonna use 4 more of them, so. Just gonna hook these up to the texture asset. Move them closer together, like so. And these are now diagonal directions in this direction and this direction. But how do we make these directions? Let's see, what was the logic behind that? I have it here in on my cheat sheet. Alright, we gotta do a subtract and an add, and then an add and a subtract of both of the U, V, and then adding U and subtracting V, and then appending them together. Here we go. Boom, 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 and boom. Hook that into the UVs. Like so, and putting them onto the add node. Now we also need to add these like so together, and then multiply it again by 2, or dividing by 2, which is multiplied by 0.5. And hook it up into there. Now we have combined all of them. Compile should work, unless I did something wrong. Nope, I did not. Now we have many directions. We also have diagonal directions. As you can see, if we hook this onto there, just the diagonal directions, hit compile. Now it's only diagonal. Looks kind of neat, right? Could use this for like a bloom shader, like a glinting bloom, right? But yeah, now we have 8 directions of displacement of the pixels. So now it's more, it looks a lot more blurry, right? Yeah. So let's go into the game view and let's see how it looks with the... Yeah, it looks kind of blurry, kind of. Reflections are seen. Oh no, we haven't set up to also use the back faces. Let's do that. Go to geometry, face culling, set it to double-sided. Hit compile, and now it should have back sides. Yeah, nice. So how do we make the... Well, you probably haven't, or I didn't say it, but you need to set all of these here, which you want to apply the glass texture to, or the glass material, right? You want to set them to like a layer that you haven't, that you're not going to use for like things that you see, so transparent effects, or create a new layer. And you just set all of the glass, all of the ones that are supposed to be transparent on that layer. And then on the transparency camera you also need to set the culling mask to not see the transparent effects. Can't believe I forgot to mention that, but yeah, otherwise it would see itself and yeah, it wouldn't look too good. It'd probably start looping onto itself each frame. What more can we do to make it look good? Well, we can make a glossiness map, adding glossiness maps onto it, so it actually like uses a texture to also make the displacement of the pixels. So you can actually have like a tempered glass or whatever. Let's create a texture 2D now, call it glossiness map, and multiply the R value by the glossiness strength, and there you go. Compile. Now we have a new texture input. Let's find a texture. Stained glass specular. There we go. Go to the game view. I forgot to close the Shader Forge window, but whatever. So yeah, looks kinda good, right? I think it looks kinda good. You can already see the way the pixels are displayed, or displaced rather, within the shader itself, and also the PBR of the reflections, right? So now we're making PBR glass. That's a good thing. I think so. It looks good. But we can make it look better. We can also add, let's see here, we can make it also use normal mapping to displace itself with normal maps. Where should we put that? It's kind of like a mess right now. Place them above each other, like there. Organized, kinda. Move this whole thing somewhere, I don't know. Alright. Create a new texture 2D, call it normal map. We also want to set its strength, so create a component mask, RNG, multiply that by a slider, call it normal strength. Oh yeah, set the normal to bump and normal. Create an append node, a value node, set this value node to 1. Hook these two onto each other, there we go. Create a set node. Let's call it normal map. Hook that onto there. And now we're actually gonna affect this screen position thingy. So create a subtract. It seems subtraction looks the best when creating refractions. Boom, bada boom, bada boom. Multiply it by, hold on, let's move it up there, by a 0.05. Otherwise the refractions would look really strange, would move quite far. So you need to create a get node. Well, you need to make it smaller. Make it a lot smaller actually. Normal map with this outputs 3 nodes, so we need to make a component mask. 3 values rather, and RNG, because we're only going to affect 2 values, the U and V, so we need the red and green channel. Multiply, subtract, and screen position. Like so. Hit compile. Now we have more. Let's just move these things around to make them a lot more organized. Hit compile again, just save it all. On the texture map, texture input, hook up a texture map of your choosing and watch it be displaced. Boom, there we go. But it's not moving the specular because we haven't hooked it up onto the material itself. Normal map, normal. Oh no. There we go. Compile. We don't really need metallic, so we're just gonna keep this 0 value node. And now it also moves the speculars. Let's go into the game and look at how it looks like, shall we? I think it looks good. The way it displaces the pixels and also creates like a blurriness to it. We can also, we don't need to use like a stained glass, we can use like, let's see, do I have anything else that could look semi-good? I don't know, noise perhaps? Yeah, let's see. Glossiness map and this onto the texture, normal map. Looks almost like ice, kinda, if I make it white. Kinda looks like ice, refracted ice. Oh, there's a phone ringing in the background. Yeah, never mind. So this texture is kind of big. Or the values are a bit meh. Whatever. At least it works, right? Yeah. So we already have now set up a lot of logic for like making it look better. Yeah, I think that's actually it. I don't think there's anything else. We could make like add a texture map to it. Call it, I don't know, texture map, or like a diffuse map. So you have a texture also onto it. Don't think there was anything else. No, that was it. Now, with that created, we have a fully functional glass shader. Just move that up to the top. So if we hook up like a stained glass texture onto there, ignore the glossiness map, but create or set up the stained glass normal map. Set it to something not too much. And hold on, let me just set the movement speed a bit less. There we go. Tempered glass. And with all of these, does it actually see that box? If I move it up like, I don't know, put it here, front of it actually, like so. Set the glass texture to not have there, and go into it. Because we could like make, it does see it, but it's not too intrusive. Oh, that's pretty good. That's pretty alright. There is a post on the guide on the forums where you could like mask out the things that are in front of whatever glass you're making. Could make that onto like a follow-up video. But here we go. This is glass. Glass that works. Good. Alright, I think that's it. It's a kind of long video, but I think it'll do. It'll do. It's sort of by the numbers tutorial, I guess. Alright. Big shader. A lot of things. Not too complicated. Hope this helps. Take care now. Bye bye.